keeping yourself audio and video muted and becoming, so I would like to have interactive session rather than simply I keep speaking.
Yes, sir.
So I will be interested, all of you to in between inquire that how are things. So Rajesh is here, of course, he's our student, so he's another student who is, and then I want to know from others too. It should not be the simply muted spectator and then don't interact. So
Yes, sir.
your interaction is equally important. So, dear student, let me share. Professor Mishra has already sent you the, like this our lab notes so that you can have preliminary acquaintance with the topic. So he has requested me to take two classes, one lab class, one was on sprinkler irrigation system, another one is on drip irrigation system. So these two topics are very important from irrigation point of view, and I understand you have been taught micro irrigation. Can I know that, yeah, whether it is taught sprinkler irrigation and drip irrigation system in your theory class?
Yes, sir, it is taught.
Okay. So I hope you will be able to follow fully what I'm speaking because it has been taught, and then Professor Mishra taught or Dr. Damodar has taught you? Who has taught you?
Sir, Mishra, sir, only.
Professor Mishra has covered. Okay. So very nice. So right now I see here 28 including me. There are total 28 persons including me and two of my students here. So anyway, without discussing any other thing, let me come to the topic. So today your lab class is on the your identification or eval means of the uh, sprinkler irrigation components and how to evaluate a sprinkler head. So uh, if it has been already taught to you, just I will refresh your things. The sprinkler irrigation system as well as drip irrigation system both falls under the category of pressurized irrigation system. Pressurized irrigation system means we are creating additional pressure to operate irrigation system. Now, since we are operating by providing using a pump or overhead the system, it could be over a tank. So, and then creating adequate pressure so that the water emission devices, it could be over a sprinkler or micro sprinkler or micro irrigation components that can be operated. So desired pressure can be created to operate the sprinkling device or dripping device. That is the important part here. Now the why micro irrigation system, why sprinkler irrigation system, this question comes because you have a better control here. You are control in the sense that you are uh, depending on the availability of water, you can supply desired amount of water at a specific location. Suppose area is very large and it is a hilly region. By simply other methods, gravity methods of irrigation where surface irrigation is being given, it is not possible to apply water when source of water, let us say, it is available at the foothill and water is to be supplied on the uphill where the plantation or crop is being grown. So you can have a control, you can create adequate pressure so that the water can be applied at each and every point of the field in the desired quantity. So this is the main feature that here. Now when it comes to the sprinkler irrigation system, so for sprinkler irrigation system, what we are doing, we are uh, creating adequate pressure, and then water is supplied with by using the network of pipeline, and then on these pipelines sprinkler riser and sprinkler head is mounted. So water coming out of the sprinkler head, it is resembling rainfall. Like rain, it is, water is allowed to fall on the ground surface. So there are some specific advantages of drip irrigation or my sprinkler irrigation system. And Government of India, Ministry of Agriculture uh, and Farmers Welfare uh, is very much promoting this method of irrigation. So about 12.908, or rather we simply I can say 13 million hectare area is under micro irrigation system, in which about 6.8 million hectare is under sprinkler irrigation system, and 6.11 million hectare is under drip irrigation system. So Government of India is promoting giving subsidy to the tune of about 50%, and there is a scheme called Prime Minister Krishi Sinchai Yojana. Try to understand that there is a scheme to promote sprinkler irrigation system, to promote drip irrigation system. Government of India has introduced Prime Minister Krishi Sinchai Yojana, and there is a slogan, there is a specific task or mission it is given: per drop more crop. Per drop more crop is the emphasis of Prime Minister Krishi Sinchai Yojana, where there is a provision that each and every point of the field it can be irrigated. So Honorable Prime Minister has given a mission that each and every piece of the land should be irrigated. Har khet ko pani. This is the slogan given by our Honorable Prime Minister, Har khet ko pani. And this is because we have a limited water resources. We cannot simply by surface method of irrigation, we cannot irrigate entire our land, agricultural land. So in order to bring more area under irrigation, these methods of irrigation where you have control, you can supply water, that is possible to give. So this is the mission. And just now let me share that what are the different components of a sprinkler irrigation system. So let me hope it is visible.
Yes, sir.
Yes, sir.
So first let me introduce you with the what are the different components of a sprinkler irrigation system. So here what you are seeing, there is a source of water, and this source of water can be a pond water, it can be a river water, it can be a the groundwater. And then, as I told you, sprinkler irrigation system, it falls under the category of pressurized irrigation system. Pressurized means you need to create adequate pressure, so that with here at this point where I'm putting the our cursor. So in this cursor, what you are seeing, there is a sprinkler nozzle. sprinkler head. So this operate at a specific pressure. So with the help of a pump, you can apply water and then these sprinkler can be operated. So what we are seeing here from the source of water, it is a pumped by using the pump. This pump can be coupled with a electric motor or it can be coupled with diesel engine. So what we see here, there is a suction line of the pump. So a pump has got two ends. One end is suction end and another one is delivery end. So this is the suction end, suction pipeline, and then suction pipeline is provided with a coupling where the pump is connected. So there is a pump and pump is coupled with an electric motor. So electric motor gives dry to the pump and then there are set of valves. One valve is check valve, another one is a gate valve. Check valve is basically meant that water which is allowed to flow in this direction, it will not allow the water to come to the back side. It will not allow. Whereas the gate valve, it is to regulate the flow. Whether we are required to operate with the full throttle or we can have a smaller amount of flow rate. So this is a gate valve which has been provided, and depending on this, whatever there are different connections you are seeing here, there is a coupling, there is a check valve, all these are optional features. It is not always desired to have so many valves, so many connectors, but here it is shown if required we can have different coupling. So here it is given there is a main pipeline and main pipeline has got telescopic union. Telescopic union, initially the size of, let us say, pipeline is large, but you want to reduce or you want to increase the size of the pipeline. So this union is provided. Now when water is being given from the main pipeline, it can be supplied on either side of the main pipeline, either this side or this side. So when we are connecting from the main pipeline, a lateral pipeline is attached by using the T. This is your T valve or simply T coupler. T means the shape of this one, that there is a, it is a this, and then water can be diverted to the perpendicular direction. So this kind of a coupling devices are possible. So here water is diverted and then there is another pipeline which is known as a lateral pipeline. So lateral pipeline is connected and then on this lateral pipeline sprinkler node or another pipeline which is attached, which is of smaller in diameter. Say let us say that it is about a quarter of an inch or it is a 1 inch in diameter. Normally this is 1 meter in the length and so are 90 centimeter in length, and the one side of this pipeline which is known as a riser pipeline, this pipeline which is extended vertically attached with the lateral pipeline, there is a riser pipeline and one end of the riser pipeline is connected with the sprinkler. So these things you can simply, I can tell you, if you are coming to the class in the physical mode, you could have seen by your own eyes. But since you are interested only on the offline, online type of a thing, so you are just seeing the figure. All these things are available in our lab, and you could have seen the operational part of a sprinkler, live part you could have seen. But Professor Mishra told the students are interested to attend only online, so therefore I'm just putting here. So this is a lateral pipeline, and in order to terminate the lateral pipeline, end plug is provided. End plug is provided. Now then it goes to the main pipeline, and you want to have water to supply in the another direction. So an elbow is used, that is a 90-degree bend. A 90-degree bend or elbow is provided. These are now available in variety of material. Earlier it used to be the alloy, cast iron, as well as aluminum. Now PVC or HDPE, plastic pipelines are being used for sprinkler pipelines. So elbow is provided, and this elbow is connected with another sprinkler pipeline. And then these sprinkler pipelines, these are normally of 3 meter, 6 meter or 9 meter long, having the diameter of 2 inch, 2.5 inch or 3 inch in diameter. And the same way there is a riser pipeline, and on the riser pipeline sprinklers are mounted. So these systems are allowed to move. It can be once the irrigation is being done, you keep on moving the sprinkler on this direction, and this may go this direction. Accordingly, the irrigation is being performed. So this is the one of the methods of application of water by using the sprinkler irrigation system. I understand. Is it clear? And
Yes, sir.
you might have been taught by Professor Mishra these things. Hello, whether
Yes, sir.
you have been already exposed to this particular components of the sprinkler irrigation system.
Yes, sir.
Okay, so just this is, I'm repeating same thing so that you can have the understanding. We will be now showing you. So this is another way of means to show you here the water is being pumped by from a well, and then this pipeline is your main pipeline. This is the lateral pipeline, and on the lateral pipeline you can see there are these are the couplers, means this is one pipeline of this length, and then a cup by using when we are joining. It is not that the entire pipeline is such long it is available. No, these are available 3 meter, 6 meter, 9 meter long. It could be any, depending on the requirement one can choose, and then they are connected. So one pipeline and another pipeline can be connected by using a coupler, and on this coupler a riser pipeline you can see here it is mounted, and then a sprinkler head is attached. So this is the way, and then this is a simple kind of a system which you are seeing, which is adopted by our Indian farmers, whereas in developed countries this type of system is used where the size of the farm is very large. It could be a 50 hectare, 100 hectare, and at a stretch the irrigation is being given for such a large area. So that is a central pivot irrigation system which is used. But in our country this kind of a sprinkler irrigation system, it is used for majority of the crops, leaving aside your jute and paddy. All the crops it is possible to irrigate, that can be done. So this is all which already I have explained you. Now coming to the sprinkler nozzle, sprinkler head rather I will say, sprinkler head. This is a typical sprinkler head, and on this sprinkler head you are seeing there are two nozzles. So one nozzle is a spreader nozzle, and this is a range nozzle. The diameter of range nozzle is large, and as compared to the spreader nozzle. And as you see here, there is a slot which is cut here. So this slot is purposely meant for applying the water near the sprinkler system, whereas range nozzle, it is spreading the water at a larger diameter. So this is a spreader nozzle. Sometimes though it is written known as a, not sorry, this is not a spreader nozzle. This is a range nozzle. So range nozzle, it goes as a larger distance. And now when water enters, because this part is connected with a riser pipeline. So water enters here, it comes at a pressure. So because of the high pressure, so it what happened? It compressed this is a spring loaded arm. So this spring compresses. The moment spring compresses, the water it the comes out, and because of the high pressure there is a pressure water which is coming with the pressure. So the water coming out of this, what happened, it strikes on this particular vein of the this spring loaded arm. So this part it is a load, and then when it this jet eject out of this, so this hits, and this hits in such a way that this is arm, it deflects, but there is a counterweight impact arm, it brings back to the same position. So it keeps on, so when it comes on the same position, this revolves, and this causes so there is a torque develops. So water which is coming and it is coming out of this one, this develops the torque, and that torque, this continuous, deflecting the spring loaded norm, this causes the sprinkler, the nozzle to revolve on its own axis. So this is a impact type of sprinkler nozzle, impact type of sprinkler. So, and this entire assembly is known as a sprinkler head. This is known as a sprinkler head. More than 100 companies, they manufacture sprinkler nozzles. So these are the different types of. This is one company name, that is a Rainbird company. Now in India there are quite a good number of companies, they manufacture these sprinkler heads. This is a pop-up sprinkler, mainly for irrigating the lawns, etc. Now any sprinkler system, when it is operated, what happened? There is a typical, this kind of a water, when you are monitoring the depth of water, so the depth of water from a particular sprinkler head, it looks like this. Now if suppose this this is your diameter of coverage of one sprinkler. Okay, so if you are keeping a this is, say, let us say d meter. So d meter, so another sprinkler you are keeping at 50% distance, that is 50 another, so there will be overlap. Now this overlap of these two sprinklers is important. So for uniform application, we are giving overlap of about 50% to 60% of overlap in order to have a uniform depth of water application. Now if you are not having enough overlap, so what will happen? The depth of water applied over the ground surface, it will not be uniform. Very much desired, and this overlap will repeat it. But this ideal structure, and this may, depending on the direction of the wind and then the wind speed. So this is a uniform. Our aim is that this would be the uniform depth of water to be applied below the ground surface in order to weight the root zone depth. So this is a non-uniform way of water application. If it is so, what will happen? Some part will get water, more water, some part will have lesser water. So depth of water application is important. Now, so this is the type of thing which I have told you. Let me tell you something more about the other part. Let me just see here. No, no, no. This is not. Hope. So a sprinkler system. Once again, I'm telling here. It includes a chemical or fertilizer application. There are set of control. There is a main pipeline. There is a lateral pipeline. There is a water meter in order to monitor the amount of water which has passed through the pump. Then there is a riser pipeline. There are pressure heads, pressure gauges in order to monitor at what pressure this system is being operated, and what is the inlet pressure, what is the pressure at the sprinkler head. In the pipeline, there are valves. Those valves are meant for releasing the air. So we call it as air vent. Air vent is provided to release the out of the pipeline, release the air entrapped in the pipeline in order to prevent the water hammering action in the pipeline, or water breakage should not break the pipeline. And then finally, what you see that there is a sprinkler head. Now you have already seen a sprinkler head, which this sprinkler head, it is basically, it consists of two nozzles and then a spring-loaded impact arm. And then there are end plugs. So end plugs, as the name said, that at the end of the pipeline, whether it is a main pipeline, whether it is a lateral pipeline, at the end of the pipeline, there are plugging system in order to close the pipeline so that the enough pressure it can be created. Now I was telling you how to evaluate the sprinkler system. So one of the the evaluation parameter is what is the discharge of a sprinkler head or discharge through a sprinkler nozzle. So sprinkler, at what pressure it is being operated. So if H is nothing but the pressure head, that is the pressure head, and it is a orifice flow formula. Simply it is a orifice flow formula. The discharge from a sprinkler nozzle is considered as discharge from an orifice, which is nothing but coefficient of discharge multiplied by the area of sprinkler nozzle into square root of velocity head. Square root of velocity head, that is root 2gh. So g is the acceleration due to gravity, h is the operating pressure. So as I told you, the pressure head is required. So pressure head is known. If I know the diameter of the sprinkler nozzles, so both if it is a twin nozzle, so we need to know what is the sprinkler nozzle diameter, and accordingly one can find out the area of the opening of the sprinkler, and accordingly the discharge can be computed. So, and g is the acceleration due to gravity. Now if we are evaluating, there are two sprinkler nozzle, so we can write total discharge from a sprinkler head. It can be given by the CD into A1 root 2GH. So I told you there are two nozzles. One is spreader nozzle, another one is the range nozzle. Their diameters are known. If the coefficient of discharge is known, and then operating pressures are known, one can find out the what is the discharge, total discharge, individual discharge of the from the those nozzles, and then summing these discharges, one can know that what is the total discharge from the sprinkler head. Then another parameter of evaluation is rated weighted radius of weighted area. Of course, this is a empirical relationship which one you can find out. Simply measure. Suppose sprinkler is operated at a given pressure, and then what is the radius of weighted area? Because this is a circular it makes. So if you measure, then and at a given pressure, you can say, yeah, this is the thing. But empirically, this is given by R equal to 1.35 square root of D into H. What is R? R is the radius of weighted area. That is how when it is operating, that what is the diameter or radius of weighted area, and then diameter of the nozzle, D, the diameter of nozzle in millimeter, and H is the operating pressure in meter. So if you are substituting these values, you can know that what is the radius of weighted area. This can be compared. Now then another parameter of evaluation of a sprinkler head, it can be breakup by jet index. What is the breakup index? We can say breakup jet index. That is given by PD. Now this is evaluated by taking using this expression, which is given by PD equal to H by 10 Q to the power 0.4. H, as I told you, it is operating pressure or pressure head at the nozzle. It is in meter. PD is the index, and Q is the discharge of sprinkler in liter per second. And now if you are substituting the values, if you have the value of H, know the pressure, what is the discharge, then you find out the PD value. Now if PD is less than 2, we say this is a moderate, not mid, it is a moderate sprinkler is operating moderately well. But if PD is equal to 4, we say that operating pressure is good, it is a best operating pressure, and sprinkler should be operated at this pressure. If you find PD is greater than 4, means operating pressure is considerably high and which is not desired. So according to this index, one can say that the pressure which is being applied to operate the system high, we are wasting the energy. Then another parameter of evaluation is given by the revolution. So if revolution made by the sprinkler is 0, means you are measuring that this particular system, then you find that if it is a 0.67 to 1 RPM, then we say revolution per minute, then we say it is slow, and 0.25 to 0.5, it is normally meant for a large sprinkler nozzle. Now, a very important parameter of water. Just few minutes back, I was telling you how uniform water is being supplied. So we need to actually divide the area when we are sprinkler, it is spreading the water. So 1/4 or half circle we can divide into number of grids. These grids could be of 1 meter or 1.5 meter square inch shape, and then you are placing the cans. You are placing cans and collecting water. When you are placing and collecting water, and then when there is enough, when sufficient amount of water, measurable amount of water, we evaporate it for 2 hours or 3 hours. So the measurable quantity of water is collected in these cans, and these can water is being, collected and analyzed. When you are analyzing, so one of the analysis is known as uniformity of water application, which is also given as the uniformity coefficient. The uniformity coefficient is estimated by using the expression that is 100 into 1 minus summation x. This x is nothing but absolute, the x it is absolute deviation from the individual observation. It is a numerical deviation. So what happens, suppose I'm just putting it, there are, let us say, 20 number of observation, 20 number of cans in which the water is being collected, and these 20 values, you are finding out the average value, and from each individual, from this mean value, what you are doing, you are finding out the numerical deviation of x1 minus x bar. X bar is the mean. So like this one, there will be 20 deviations values. Now sum of the deviation, you are taking absolute value divided by m into n. M is the mean value and n is the number of observations. Let us say there are 20 observations. So 20 into m will be used in the denominator, and absolute deviation from the mean will be used to find out the value of x. So we need to sum those values, and then 1 minus summation of sigma x divided by m into n multiplied by 100 will give uniformity coefficient. Now this coefficient of uniformity are of about 85% or more. If we are getting, we say that it is satisfactory. If it is less than 85%, means we have to see that the pressure operated from to operate this particular system, is it sufficient or it is more. Accordingly, we will regulate. The another observation is pattern efficiency. Pattern efficiency said, I told you that there are 20 observations. So whatever is the minimum value, that minimum value divided by the average value, that is m, that will be used to find out the pattern efficiency. Now pattern efficiency, higher the pattern efficiency means we are getting better uniformity, better pattern of water application beneath the sprinkler. So these observations means we are collecting what is the pressure of water, we are collecting what is the discharge from the small nozzle, what is the discharge from the large nozzle, and then you are collecting data by putting in the circle, these are the nothing but radius. A is the central place, or O is the central place. A and B, C, these are all the radius values on which the cans are placed, and these cans data are being used to find out the average value of this particular row. Accordingly, these values are collected, and then we calculate the statistics. So OA, OB, OC are the lines on which the cans are put up, and O is the center of sprinkler area over which the sprinkler head is kept. So these are the things. Now I will supply you this particular these data. So what the data which are available, data means what it is, that is operating pressure was 1.4 kg per square centimeter. The diameter of a small nozzle is 3.175 millimeter. Diameter of large nozzle is 5.563. And then another observation what we found, total discharge means discharge from the spreader nozzle, discharge from the range nozzle. The sum of these two discharges gives the total discharge. So discharge is known. You have the operating pressure we know. So you can calculate many other parameters which I have told you. And the time of, there were 5 revolutions. 5 revolution takes 2 minutes 31 seconds. So you can find out how many revolutions per minute it will take. Accordingly, you can categorize whether it is a slow nozzle or it is a moderately operating nozzle. And then you can see here, there are, these observations. You can see here 6, 1, 2, 3, 4, 5, 6. So there are 36 observations. There are 36 observations. These 36 observations are discharged in milliliter. These data which has been collected. Now these data you can use for calculating the uniformity coefficient. So this is your the data supply which I will pass on to you after the class. Little more going to the little more. Let me just show you. There are, how does the sprinkler set will look like. So the data which I have collected, you can see here. We have a sump, and from the sump water is being taken. This is your suction pipeline. Okay. Then let me show the next one. Sorry. Let me show the next one. Just a minute. Yeah. So this is the suction end. This is the delivery end. There is a panel board on which the this your date means the electric supply can be given, switching on, switching off, and this is the delivery end. And this particular end you are seeing there is a pressure gauge mounted, and this end there is a control valve, and then water from the delivery end of the pump is being supplied to the main pipeline. Okay. Now this one, let us see. Yeah, this is same thing. This is a sump, and this is the water. So water is being coming. This is coming to the pump motor, and then supply is being done. Okay. This you are seeing how the sprinkler is connected. So this part you see here, this is one pipeline, which we call it as a lateral pipeline. This is the lateral pipeline. And these two pipelines are how they are joined. There is a coupler, and on this coupler, the riser pipe is mounted, and on the this riser pipeline, there is a pressure gauge where you can see that how much is the pressure when the sprinkler is operating, and then there is a nozzle, and this side also there is a nozzle which will be there. Yeah, same thing, that this is the pressure gauge and these are the two nozzles. So before operation of the observation, we are collecting the information. Already I have told you. You can see here how the sprinkler system is in operation. So these sprinkler are attached, and then we will here the data which I have supplied you, this data has been collected by putting them in a specific distance in a grid. We have made the grid, and then accordingly the data were collected. So this is one part of the thing. Let me see what else. Okay, you can see here, I think we have a okay, no problem. I can show you here. Yeah, it is here. So just you see Once again, I will be explaining you. This is of course this will this particular thing which I have uploaded in the YouTube, so you can see more detail when it is being explained. The sound you are able to hear? Hello?
Yes, sir.
Whether you are getting sound?
No, sir.
No, sir.
No, sir. It's not coming.
Just
taken the lower end of the pipeline of the suction pipeline, there is a footwall.
whether you are able to
So
now.
footwall is the purpose of
talking
Yes, sir.
about-
footwall is
Sir,
to
yes, sir.
retain water. First, the suction pipeline, it is filled up with water up to the filling the impeller, so that it does not air, whatever air available in the pipeline, it will be moved filled with the water, and then water is means it is used for priming. It is used for priming. So a footwall, you can see here at this end there is a flap, it has come out, and when we are filling water, then this particular wall, it gets closed. That this is the purpose of footwall. Then the water is taken. This is the delivery end of the pump, which is connected, and then it goes to the main pipeline, and at appropriate location sprinklers are attached. We have taken water from the delivery end of the pipeline. So a main pipeline of adequate diameter. Normally these pipelines are of 2-inch, 2.5-inch or 3-inch in diameter, and each pipeline is of 3 meter, 6 meter or 9 meter long. So here we have taken water from the main pipeline, and then with the help of a 90-degree bend, bend, a lateral pipeline had been joined. Now, as I told you that there is a coupler at appropriate location. Coupler is used to attach sprinkler at a place where we want to give irrigation. So this is one coupler in which one lateral pipeline will be attached with the another lateral pipeline, and on this coupler you can see here that on this coupler there is a riser which is of 1 inch diameter, 1 meter long, and this end is connected with a pressure gauge. Pressure gauge is connected here to know what is the operating pressure of a sprinkler head. Now, a sprinkler head, here you are seeing this is a sprinkler head which is made up of an alloy where there are two nozzles. These two nozzles are discharging at given pressure, and one nozzle is a range nozzle, another this particular range nozzle, the other nozzle is spreader nozzle. This is the counterweight, and it comes compresses, and then a torque is created. So because of this torque, this the when the jet will come, it will hit. So once it is hitting, then
Sir, your voice is not coming.
Sir, you are not audible.
No, actually, video is stuck up. It is not operating. It's stuck. Just wait for 1 minute. Or what I will do, I will share you this thing. You can see, because I uploaded you in the YouTube. I thought it will be easier for you to show you. So I will share you this particular. Okay.
the suction end of the pump, this there is a flexible pipeline where the water is being taken. The lower end of the pipeline, this is a sprinkler head which is made up of an alloy, and then a torque is created. So because of this torque, this the when the jet will come, it will hit. So once it is hitting, then it deflects, and deflection it causes the sprinkler head to rotate. So this way it takes the one particular sense circle. Now we will be monitoring the pressure at a given pressure, how much the discharge coming out of the sprinkler. So there is a relationship which I have already explained to you, that discharge from a sprinkler nozzle is directly related with the operating pressure, which is the square root of the operating pressure. So we will find out what is the total discharge, in discharge from this nozzle plus discharge from this nozzle. Both the nozzles will be operated to know that how much discharge we are getting at a given pressure. From that data, we will also find out the coefficient of discharge from these two sprinkler, because we know the pressure, we know the discharge, so, and we know the operating pressure, we know the discharge, we know the value of G, so we can find out the coefficient of discharge. In order to measure the discharge from both the nozzles, two pipelines which were fitted with the nozzles. Now the total volume of water, it is being collected in 10 seconds, and then we will find out the volume of water collected in 10 seconds will give the discharge at 1 kg per square centimeter. Yes. This is the discharge from another nozzle. So, so individual discharges we have collected in 10 seconds, and then we will, using this data, we will find out the coefficient discharge for each nozzle, that is a range nozzle as well as spreader nozzle. Now we can see that in how much time it takes to take one round. So the sprinkler revolution in per minute, it can be found out. So this is one observation it is to be used. Another observation, what you see, there are measuring cans. So depth of water which is collected in a given time, this depth of water will be used to find out the uniformity of water distribution. Another observation which you can see here, what is the diameter of coverage. So diameter of, this is the radius, it is being measured, that how much is the wetting radius from the nozzle, which is when the nozzle sprinkler nozzle, it is operating at 1 kg per square centimeter. So we are measuring operating pressure, we are measuring the volume of water, then discharge, then we are measuring what is the diameter of coverage of wetting diameter, we are measuring the depth of water collected in the cans. This depth of water collected in each can is used to find out coefficient of uniformity, that formula which already I have explained in theory class, and we have worked out problem in the tutorials.
So hope it's clear to you. Hello,
Yes, sir.
any confusion to this point? Yeah. Any query do you have? Because I am going to take you on the next lab class. Before I start, I am going to ask questions on this, whatever I have covered. So if there is any question, some query, you can clarify your doubt. Yeah, Ambika? And none of you are speaking. So no point actually, so much time I have spent with you. Whether I'm audible?
Yes, sir.
Yes, sir, you are audible.
Yes, sir.
So any query you have, I want to ask you, or if you are clear, should I ask question from you? The data, which I was just discussing, the data in that particular sheet. So those data will be supplied to you. These data I can once again tell you. Here I can show you those data if I am not wrong. Okay. No, yeah. Yeah. These data, just telling you that in the given data, you have been given operating pressure, you have been given the discharge of, diameter of smaller nozzle, diameter of not large nozzle, then you have a total discharge. So diameter is known, so you can find out the area of nozzle. Total discharge is, so individual discharges are also calculated. So we can calculate the the coefficient of discharge. Is not it? So you get the CD1 and CD2 coefficient of discharge because you have got the Q1 equal to CD into CD1, rather I should say CD1 into A1 square root 2GH. So H is your nothing but 1.4 kg per square centimeter, which you convert in simply if you multiply it in the water column, so it will be 10 meter of water column, it will be 15 meter. So 15 meter, 14 meter, 1.4 into 10. So this becomes your 14 meter. So H is known, root 2 GH. So you can get CD1 as well as CD2. Then next part is your revolution per minute. The total revolution in 2 minutes, 5 revolution, it has taken 2 minutes 31 seconds. So RPM you can find out how much is the RPM. Then diameter of coverage, of course, it is not given to you. So anyway, diameter has not been given, but so this has not been given. So OA, if I know what is the OA, O is the center, and ABC, these are considered as the radial distances from the center. So OA, OB, OC, these are the radial distance. Rather than making the grid, they are put up at equal, so in the circular form it is kept. So OA, OBC, OC, all these are, and then these are the corresponding, volume of water which has been collected in each can. So from these data, you find out from 36 number of observation, you find out what is the, the average value, average volume, whether you can say, and then get the deviation from these values, get the deviation from the mean. So this is your xi minus x1 minus x bar, whatever x bar you are getting, and this will be 8.9 minus x bar. Then if you are taking it, this is your x2, this is your x3, this is your x4, this is x5, x6, x7, x8, like this. You can have either way, and then like this, you will be subtracting and getting the summation of these deviation. So find out this one, and then from all these observations, you can also get the pattern efficiency, pattern minimum depth of water from all the 36 number of observation. So just you find out what is the minimum value among these observations. Can you tell what is the minimum value in this table? Least value. What is the least value?
Sir, 6.6.
What is the least value here? Now in this column you can see here 7.4. Whether there is any value less than 7.4 here. Seven point six, 6.6. If you see here,
Yes,
6.6, 6.8. So 6.6 is the minimum value. So 6.6 divided by the average of this will give us the pattern efficiency. What else we have to find out? Pattern efficiency. Yeah, you find out what is the PD. Breakup of genetic index. What is PD? And similarly, you can also calculate what is the, because this value, of course, we have not measured here. Data is not available, but you can estimate by using the empirical formula. So you know the operating pressure, that is 14 meter, and D is known, that is the diameter of nozzle. So take bigger diameter because that is spread nozzle. So that is given to us, that is 5.575, I think. Yeah, 5.563. So this diameter is of the nozzle is known, that is in millimeter, and operating pressure is in meter. So substitute and then you get the value of your radius of weighted diameter. Okay. So I will supply you this particular table and try to not try, rather you submit this particular lab with all computations. Fine.
Yes, sir. Fine.
Okay. So this is your lab class, and for today's lab class, any query, anything which you want to ask on this? If no, then okay, then I will share you this information in your. Thank you.
Thank you, sir.
Thank you.